Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to drop back and cover kind of an update on where things are with ARM on any platform. It seems like. So I have some crow to eat, and So anyway, what I'd like to do is to kind of take a step back, and let's talk about in the world of computing what has really been going on with the monumental shift from moving from x86 over to, let's say, ARM, for example. So yeah, we have some very powerful companies that are involved here. We have Intel and we have AMD. Also, Apple is another one, and of course Microsoft themselves. So the challenger being ARM has long been a go-to for mobile devices. With almost anything that is sold today has an ARM chip in it of some kind. But it recently, as of about a year and a half ago now, it has been starting to try to make a play for the desktop, and it has been pretty successful in the enterprise markets already. So, and that's leading the way also into AI computing as well. But I think the road ahead is far from smooth. So this is my story about how I'm on ARM, and we're gonna kind of contrast it with Apple's M series chips. And I think ARM and Apple have been reshaping the landscape. But how did the Qualcomm Snapdragon chip shake out in the end? So yeah, I mean, we're looking at it from the standpoint of their early hype and the struggles that they have had to make it a significant dent in the PC market share. Well, I think we better take a roll back into the 1980s to where this whole thing started. ARM on PC desktops is not new. He's with a small British company called Acorn. They saw the future of computing, and it wasn't because of traditional computing complex processors, but rather that RISC, reduced instruction set computing, offered a means of not only simplifying the instruction set, but also increasing the amount of power efficiency. ARM has a unprecedented history for power efficiency, but can this new architecture really penetrate into our daily lives beyond the cell phone? Can it replace our desktops? Can it replace our laptops? So let's fast forward into 2012. We're not quite up to 2024 or 2023 yet, but this is where Microsoft was eager to embrace ARM, and they tried to push Windows into this brave new world called Windows RT, or real time, there's other names for it, but I don't think you need to know those. With Microsoft Windows RT, Microsoft created a version of Windows that ran on ARM chips. But they left a lot to be desired. First, they didn't have good application support. And so they were counting on the developers to take their code and port it over to ARM, mostly rewrite it over into ARM and get it up and running, and then push that code over to Windows RT to pick up the slack. So despite the potential of ARM, the developers were like, well, where's the user base? Well, as it turns out, nobody came to the party, and so the developers went, nah, I don't think we need to do this. I think if Microsoft had built lessons learned from that might have kept them from repeating the same mistakes that they had made in Windows RT from occurring again when they were attempting to introduce Windows AI PC. Let's contrast it to what Apple did. So they've gone through a number of transitions. Let's just look at the Mac as an example. So originally the Macs were on PowerPC. We all were like shocked when Steve Jobs gets up on stage and goes, "Welcome Intel," and he brings in the CEO of Intel at the time, who was dressed in a bunny suit to present Apple's transition from PowerPC to Intel. So it was one of those humorous moments in history. But Apple had planned this move well. They did three things. One, they introduced something called universal binaries. Universal binaries allowed a developer to recompile their code, and both sets of code, both the PowerPC and the new x86 code, would be installed on your machine, and your machine would pick which one to run. The developer had very little to do with that. There was some, of course, there's the inevitable changes that you're going to run into between one architecture and another, but they weren't big enough to prevent the developers from doing them. The second thing Apple did was they introduced something called Rosetta. And Rosetta would allow you to continue to run your applications on native PowerPC, and it would translate that code to x86 as it executed. The early days of Rosetta had a few issues with performance, but Apple quickly ironed those out. In the early days, it wasn't all roses. Rosetta, no pun intended. Rosetta did not actually perform as well as they expected, but nonetheless, it was good enough as a bridge to get you over while the developers worked on moving their code base into the universal binaries. And so, that was a pretty big move, and it contributed to Apple completing that. I think they had initially slated 5 years to complete the migration of their entire product stack over to x86, and they completed it in less than a year, mainly because the developers stood up and said, yeah, okay, we can do this. The second part of this was that they also had their Apple Store, which allowed users to pick up this new code seamlessly and without having to go and look for it to download it. It would say, hey, you've got new versions of such and such, just you want to go ahead and install them. And once they did, they had native support for the x86 platform. So Apple had learned and had planned well for this transition. So they didn't fail. They didn't fail at all. In fact, the x86 was a pretty successful move for them. When they were ready to make that transition again, the x86 was x86 has a lot of power draw, and we all know that. Anybody that runs any x86 knows that it's inherently uses a lot of power. Well, Apple obviously wants to improve the battery life without actually having to keep expanding the battery larger and larger to be able to meet the needs of these power-hungry CPUs. So they were looking to transition off of x86 and onto ARM. So they already had the three legs of the stool, I should say. So even though it is always a risk to move from one platform to another, Apple already had their strategy in place to be able to do this. They had Rosetta 2, which would move from x86 to ARM. It would do the translation on the fly as you were running the code. So you could take advantage of applications that were still written for native x86 and still run them on ARM just fine. Yes, there was a slight performance penalty, but again, it wasn't enough that somebody would say, oh, I'm not going to use this, it's too slow. It was slightly noticeable, but it wasn't as bad as a lot of people would have thought. They also had a development strategy. They improved their universal binaries to include ARM-based code, and they even simplified that to the point where it was almost just a recompile, almost. Yeah, there was still some things they had to iron out with some things. But all in all, coupled with the App Store, that made everything pretty much seamless again for users, and they completed their full stack. And I think that took a little longer because they still weren't real sure what they were going to do with the ultimate Mac, the one that's a kind of a desktop that's upgradable. Apple, through acquisition and then through planning, started to build their M series designs. And not only did they live up to the hype, they exceeded the hype. That's amazing, because if you can get past the hype and you can actually deliver something that's better, well, yeah, your users are going to stick with you, because they actually reduced the price initially of the machines, and they released the Mac Mini with the M series. I believe was the one of the first, not the first. That they also had the iMac as well, was one of the first ones to be released. But that created a perfect storm for success. Enter Qualcomm, and this would be around October of 2023. They get up on stage and they say they have a chip that's ARM based that can beat Apple, that can beat Intel, that will take less power. And I bought into the hype, as like many of us did, and believed that might be possible based on what we had seen with Apple. We thought, oh, well, maybe it's because of ARM. Oh, such naivete. Unlike Apple's integrated approach, Qualcomm's efforts proved to be scattered and incomplete. Despite their initial promises, the Snapdragon X Elite saw a disappointing market penetration. With Tom's Hardware publishing, they had only sold about 720,000 units by October of 2024, and that represented just a 0.8 market share. Coupled with the fact that they had done their performance comparisons against the Apple M2, Apple had already replaced it just a few weeks after their announcement with the M3, which proved to be more powerful than the Snapdragon. It was on par in some areas and faster in others. So why did Qualcomm, let's say, how did they miss the mark? I don't know if I'd want to say fail. They're still building them. So I think the slow development of both Windows, so in part Microsoft's legacy of not learning anything from what they had done with Windows RT. And, it's kind of akin to, let's try the same thing again and see if it works. That, Einstein said, was the definition of insanity. If you don't do anything different, your outcome is going to be exactly the same. Plus, there was their version of Rosetta was horrible. Even in the RT days, it was terrible. It added a whole layer of things being slow. The gamers quickly found out that if they ran on the Snapdragon, that it wasn't just slow, it was unusable. Yeah, it was too slow. So, that wasn't going to work. You needed to have a similar type of translator that would have been fast enough, it would have said, well, a couple of frames, okay, yeah, maybe I can live with that for a while, as long as I know the developers are working on coming over with a native ARM. So, and there, with no Rosetta, no actual performant version of Rosetta for Windows, no universal binary support, no app source support. You have the perfect storm for a failure, because nobody's going to want the thing, right? Plus the fact that there was a lot of interest by Qualcomm, and they were pouring money into moving it, not only supporting on Windows, but they saw Linux as another place that they should invest, and they were, until they weren't. So what happened? Well, if we look, we need to look back here. Again, we need to look back to Apple. So just after Qualcomm brings out the Snapdragon and makes all these claims about being faster than the M2, a couple of weeks later, Apple shows up with the M3 and goes, ta-da, we got this. And, oh, by the way, it performs at not this level, but this level. And now Qualcomm is just another product in the running. And there's nothing compelling about moving to a Snapdragon X Elite. So could they compete with the M3's performance? In some areas, yes. In some areas, no. But when the M4 was hinted at in June of 2024 at the WWDC conference, that was the beginning of the end for Qualcomm, because now people were like, well, why am I bothering? There's this M4 that's coming, and it's not just here, it's up here in performance. So, yeah, and by September of 2024, Apple had launched the M4 in the iPhone 16 Pro, and that sealed Qualcomm's fate. But Intel and AMD weren't just sitting by the sidelines. Yeah, they weren't going, well, gee, gosh, what do we do now? Well, Intel releases Lunar Lake in September of 2024. Now, I'm not forgetting about AMD's Strict Point. They had introduced that at Comtex earlier in the year. Probably, we'll see, Comtex is usually around the first week in June. And they released sometime in mid-July, right? They had something out there in mid-July. So they were already there with the AI-driven capabilities that Qualcomm was promising. Apple's, and it proved itself by October when Tom's Hardware looked at the sales for the machines and found it was pretty dismal. So let's break down what was it about Apple's success and its approach to transitioning that I think you can best look at this as a three-legged stool. The first leg, as we mentioned, was Rosetta. The second leg, and just to let you know, to an engineer, the first leg is sort of like a pogo stick, right? So you can hop from one technology to another, but you can't get very far, just like on a pogo stick. It takes a lot of effort to move forward, but you can hop up and down pretty good. So you can hop from one architecture to another, but it's probably not going to be your long-term solution. The second leg is when you have the universal binary, and what that does is it provides two legs on the wire. So it's like a high wire rack. It's risky because you're counting on the developers to say, okay, I'm willing to recompile the code and make whatever minor tweaks that I got to make to that code to make it run on ARM. So that's kind of a high wire rack. It's kind of risky. Movement's possible, but yeah, you might slip off the wire and fall to your death. So the third leg was the App Store. And that provides the most stable platform. So not only does that reduce the risk because now your users are able to pick up the ARM support immediately. So unlike Microsoft, Apple doesn't just throw ARM into the mix and then go, well, gosh, I hope this works. They planned an integrated strategy between hardware, software, ecosystem to make the ARM transition smooth and successful. Microsoft didn't do that. Microsoft has brilliant engineering. They have poor execution. Let's just face it. It was kind of funny during this whole period. You had this parade of vendors from Lenovo and Asus and MSI and who else? Oh, Dell and all them that came parading on stage with the latest laptops that they made. These guys were investing in their futures with who do I bet on? Do I bet on Intel? Do I bet on AMD? Do I bet on Qualcomm? And so they were building laptops that they were hoping would resonate with people. Laptops are still growing. It's still a growing market. The PC desktop is not growing. Sorry, it's shrinking. It has been slowly shrinking for a long time. We had NVIDIA's RTX 50 series in January where they compared the famous the 5070 is just as fast as a 4090. And then in fine print it says, if you include all these AI-based enhancements, you might get the same frame rate, but that's not the same frame rate that you would get playing a game. And the benchmarks when the 4070 or the 5070 finally released proved that no, it wasn't anywhere near what a 4090 would do. As we would, I looked at that and I was like, yeah, sure, right. Yeah, I believe it. AMD's 9070 series have, I don't know if it was lackluster. I wouldn't say so. There's a pent-up demand for GPUs, and so people hopped on those real quick. The 50 series sold out in literally seconds. The AMD's sold out in literally minutes. The NVIDIA's GPUs are plagued with problems. On the higher end ones, you have the power cable fire hazard. The other problem is it's missing ROPS. We saw that on all of them now have shown up. I don't know about the 5070 yet. That's too new yet. It just got released. I don't think there's enough of them out there. I think both companies, AMD and NVIDIA, are really facing kind of a shifting focus because the AI enterprise market is drawing their eyes off of you. Gamers used to support both of them. You were the revenue stream that kept both of those companies afloat, but not anymore. It's the AI enterprise market that has directed their gaze away from you. They're building like AMD's got the MI350, the 250. Those are screamers for GPUs, but they also come with high price tags of $5,000 and up. And then, well, maybe $3,500 for the 250, and then you go up from $5,000 up to 10, 20. Yeah, you can go up. NVIDIA has the same thing going on with theirs. So yeah, I mean, here's a $1 trillion data center for you. That's probably not going to be for us. I don't think so. Unless you discover oil in your backyard in the next 10 minutes. So that leaves gamers kind of out in the cold. So gamers, welcome to second-class citizen status. That's kind of where you are. So I guess the question is the world of gaming slowly shifting to ARM? Well, I would think if you include the mobile platforms, I would say, yeah, absolutely it is. The studies have shown there's more people playing games on their phones than they are on their laptops. I think as far as my final thoughts on this is, I think I have some egg on my face I need to remove and maybe find some crow to eat as well. So in a serious tone, I have to admit I was wrong about the Qualcomm Snapdragon transition to Linux. After 9 months of waiting, I really thought that Snapdragon-powered laptops would be a solid Linux alternative. But after all this time, this is my review of the Asus Snapdragon laptop. I'm going to just do this real quick. It's simple. The Asus laptop doesn't have audio support, not for the internal speakers or the external devices that you plug in. Those will not work. There's no webcam support either. And on top of it, the fans are locked in a single speed. That makes me worry about things like being able to potentially cool the chip and how to prevent it from throttling if I throw huge loads at it. I don't trust it. It might burn up. There's other minor issues as well, but those are really the big ones that are showstoppers for me. And you want to know the ultimate irony? This is the ultimate irony. Bluetooth works, and guess what I'm using to get audio? Apple iPods. Yep. That worked great on Qualcomm Snapdragon device. That's the ultimate irony. Yeah. Here's my concluding thoughts on my 9-month review of the Asus Snapdragon X Elite based laptop. So here's what I would suggest. Save your money. Buy either a Lunar Lake or a Strix Point. Again, accept my apologies for being sucked into the hype. But, I honestly, it looked to me like they could pull it off. Unfortunately, the chain of events and the competition in the field blocked them out. So, you can't really blame Qualcomm entirely for this. You have to look back at Microsoft and go, what were you thinking? Did you really think that if you did nothing, you could just repeat the same thing you did for Windows RT and it would somehow succeed this time? I don't think so. So with that, that's all I had for today. Hope you enjoyed the video. And bye for now.